Hi everyone, I'm Kseniya, the Droid technical lead at Rakuten Viber, and I've spent last 8 years building and scaling applications that many of people actually use every day. So today we are going to dive deep into the technical challenge, how we achieve high-speed, local data transfer between Android devices. So it's not just about the moving files. We will cover the architecture we built, the low-level API we use, and the custom protocol we create to make everything work. So first, a bit of context. Viber is one of the most popular communication app founded in 2010 and acquired by Rakuten in 2014. So we connect people through chats, calls, and businesses inside our super app. So we connect hundreds of millions of users globally with the footprint more than 118 countries. So we support 44 languages to be sure that we're available to everyone and everywhere. We're not just running on the latest Pixel phone, we're running on hundreds of different device models with almost every version of Android in the countries with the varying of network conditions. So in key markets like Bulgaria or Greece, our penetration is about 90% of the population. So when you have such high market penetration, you're not just an app anymore. You are essential utility that people use to communicate. So to understand the technical weight, what we are talking today, just imagine, every 30 seconds, 8 million of users actively engage inside our app. So imagine, it's a happy day, user bought the new phone, they unbox it, signing in, download Viber, and excitement quickly turns to the anxiety when they realize that their digital soul, the years of their chat history, so the photo of their children, their work, important documents, everything just trapped on the old device. But user expected just to be there, and it's not. And they need to move it fast, without any friction. So why is that? Our biggest strength is end-to-end encryption. It means that we do not see your messages. We do not store them on our servers. So all one-on-one and group chats live strictly on the device local storage. So it's fantastic for privacy. So it means that even if our service were compromised, the user data is safe because it's simply not there. But this local strategy creates a massive user friction point when it comes to the change of the device. So we do offer the cloud backup, but the data show the different reality. So users still lose their data when they change in the device. You may ask why. So simply users do not enable the backup until it's too late, or the cloud is full, or some of the users do not trust third parties when it comes to changing their history, exchanging their history. So we started by looking at the existing solution, and we started with the Google Recommends Nearby Connections API. And on paper, it looked great. So it provides the layer of abstraction that handles, instead of you, which technology will be used. So it could be Wi-Fi, Bluetooth, or Bluetooth Low Energy. And the documentation even suggests the potential class platform solution. And with our diverse user base, it would be a dream for us. Unfortunately, we hit a critical blocker. So this nearby connection API relies entirely on the Google Play services. But with our global footprint, we have a lot of users without the Google Play services. So it could be Huawei devices or certain devices custom in certain markets. So if we used nearby connections, it means that we would leave some users behind. So we realized that we need to create the solution ourselves, and we use peer-to-peer architecture model as a base. So peer-to-peer means that two devices connect to each other without any like router or centralized control. This is high speed, secure, independent of the internet connection, and data never leaves the user physical control. So this was only the way to guarantee data transfer for 100% of our users. So to power this P2P connection, we use Wi-Fi Direct API. Wi-Fi Direct is like wireless standard that allows to create the private network on the fly. So one device became a router and another connects to that. And Wi-Fi Direct standard available on any Android device, and it like give us an option to create a solution that would feel instant. So starting Wi-Fi Direct connection is not just simply called the connect method. So you need to pass some permission gates, and you also should be sure that Wi-Fi and location services are enabled on the user device. So let's start with the old device. Old device will become the advertiser, and they will be broadcast the service. So typically, to find out what device is capable of, you need to like establish the connection. But it's time-consuming, requires the user interaction. And here, the Wi-Fi P2P DNS SD service info solve this problem. So it allows us to broadcast the metadata over the air, and devices that scan the airways can understand that here's a printer, here's a TV box, and here the Viber transfer without any connection or pairing. So to create this info object, you need to put 3 types of data there. First, it's instance name. So it's just like human readable name that other devices will see in the available devices. The second one is service type. It specifies the protocol and transport layer, and it also works as a filter to be sure that devices that discover the pair see only your service, not other printers, for example. And the third one, it's a TXT map, so it's just a key-value map where you can provide like port or version or ID, so it's like the data of your service, and by putting it there, the connected devices will know like the data about your service before establish the connection. So as soon as the service is defined, we just publish the service to the operation system, like calling the AdLocker service method, and this tells the Android framework start to broadcast our service. So by this time, all devices start to broadcast themselves. So it's like typically shutting out, I'm here, I have like Viber data to transfer, connect to me. So let's switch to the new phone. The new phone, like the goal is to find the old one and establish the connection. So to do that, we need to set up a listener and provide the service request. So they are looking for the specific service that we defined one step ago. And we need to call the discover service. So this, after calling this method, the new phone starts to scan the airwaves. And as soon as it picks a signal from the service, listener will fire. And inside the callback, we will get all info about our service. So once the service is found, we just need to initiate the connection, calling the connect method, and the underlying negotiation process will start. So as soon as connection is established, one device will become the group owner, and another device will become a client. So the group owner acts as a router, and clients just connect to that. While the Android system decides who will become the group owner and who will become a client, we can influence on that, providing group owner intent. So group owner intent, it's just an integer value from 0 to 15, when the high number means that I want to be a group owner. With the established connection, how we will move the data. So in the networking, generally we choose between two protocols, the TCP and UDP. UDP is built for speed. It's just blast packages out without any confirmation. And it's perfect for video calls or streaming when you like lose one frame and nobody cares. On the other hand, the TCP is built for reliability. It means that it guarantees that all packages will arrive and will arrive in the corresponding order. So when we are talking about transfer the user's history, when one single byte can corrupt like the whole file, of course we choose the TCP. So to implement that, we like use the standard Java sockets. So the group owner create the socket on the corresponding port, and the client just connect to this port and the IP of the service. So once handshake is complete, we have a bidirectional pipe, we have a stream, and we are ready to transfer the data. Sorry. So, however, TCP is a stream protocol, so it does not natively knows when one message ends and another begins. So what I mean, if you send to the stream hello and then immediately word, it can read as a combined string hello word, or it can read like hi and then low word. So how we could improve that? We solved this using like length prefix framing. So before sending any data, you like calculate the size of the data, it sends it as a 4 bytes header, and then like the payload itself. And on the receiver side, the receiver first need to read this header to understand how many like bytes to follow, and only after that reads this exact amount of the data to reconstruct the whole message. So this approach offers us benefits. We never guess when one message ends and another begins. We can send tiny 10 bytes message or like big a few megabytes file. And the system is encoding agnostic. So the system like treats the payload as a black box. It doesn't care if we send like plain text or Japanese characters or penguin emoji. So we do not try to interpret that. We just ship bytes as they are. So now we have all the pieces. We like establish the connection, and we actually can start transfer the data. Every transfer follows these 6 steps. So we start with the connection, then device validation, then sending the account info. After that, we need to negotiate the content types, then prepare and send content, and like restore on the device. So let's go through them. So it starts with the QR code handshake. So we should be sure that we connect to the right old device. So inside the QR code, there are like part of the data. It's a peer ID. So the new phone will know exact which service need to be found. Second, it's like validation. So the connection doesn't mean trust. We treat the connection as untrusted. So to prevent unauthorized access, we like insert the validation step, and we force the user to pass the biometric gate. So only after the user like successfully scan face or like fingerprint on some pins, so only after that the pipe is unlocked. Once validated, we need to exchange some account info, so we need to be sure that we are transferring data between same profiles and not accidentally send it to another one. So next, the devices need to negotiate what like, the content they want to transfer. So the new phone just send the request to the old one, like, hi, I want to transfer messages, photos, videos, and the old phone just checking the what on the device, what the user settings, and create the common types that will be transferred. So like after creating the common types, it just pass the types to the new phone, and new phone creates like subsequent steps about like each content type. So we start with the messages. The old device prepare like one file for whole user database, so it's a height file. And we like split these files to the segments. We call it chunks. So each chunks like around 5 megabytes. And we send these chunks together with the progress. And on the receiver side, we just reading these chunks and reconstruct the whole message. The whole file, sorry. Our approach is memory efficient, so we like lock in our buffer to 5 megabytes to be sure that the system use always the same exact amount, so it's like constant and predictable. Also, like with this chunk, we provide the smooth update to the users, so they're sure that the transfer is alive. And if one chunk is failed, it doesn't mean that we need to like abort the whole connection. We just handle the error of the specific chunk. So media transfer. Media transfer is a bit different. We operate on the loop. So we go one by one for each file. And it's like old phones send that I have this image. And the new phone must like accept or reject that. And if accept, we like divide the file to the chunks and send it together with the progress as we did last step before. And then we just, after the finishing with one file, we just go to the next one. So to make this work, we send the metadata first. And inside this metadata, we provide the ID, file size, tokens, and flags. So file size could provide to the user the option to select what they really want to transfer. And tokens help us to link the specific file to the corresponding message. So first, when the user opens like real chat history, their like file, the image is there. And second, just imagine like funny image was forwarded 10 times in different chats. We do not send it 10 times. We send it once, and tokens help us to link this image to all the places. So it speeds up the transfer significantly. So once all data streams are complete, the new phone takes charge, and the old one just stay in passive mode. So the new phone needs to run like a few steps to restore. So we like fully restore the database, we migrate all the user like preferences and settings, and we move all the like temporary files to the permanent location. So finally, it's important to clean up. It's crucial for battery and performance. So just imagine we like create a private network, we open the sockets, we transfer like gigabytes of the files. So we need to dissolve the Wi-Fi direct group. We need to remove all the temporary files, and we need to close the sockets and release the resources. So after that, the transfer is actually done. So like the user see on the new phone all like history, all the photos. So to summarize, we choose the Wi-Fi direct over the nearby connections to avoid the dependency of the Google Play services and be sure that feature is available to any Android user. Our custom length prefix framing ensure that the system is encoding agnostic, and we solve the package fragmentation issue. And the last one, we treat the connection as untrusted, so like we force some validation step together with biometric authentication. So this architecture ensures that our users' history remains secure, private, portable, regardless of the internet connection or cloud preferences. That's it for today. Thank you. And yeah, if you want, you can scan the code and connect with me on LinkedIn. I suppose we have questions on the Slido.
I just want to ask, because you have this P2P connection, and have you got any encryption on the frames that flying on the Wi-Fi?
So what I can tell you that the Wi-Fi Direct already provides some encryption of the data that is transferred. So it's there are some handshakes. I'm not sure that I can tell you everything, but files are not encrypted with we trust the TCP. And regarding the database, you can come work with us to know more, because I'm not sure that I can tell you everything.
I was curious because usually there is some custom encryption inside, so you can encrypt even the size of the frame. So you show the header and the payload, and usually you do encryption for the whole package. If someone who's middleman can see what's the
so I can tell you that first the Wi-Fi Direct, it's the channel, it's encrypted. So yeah, sure. Then part of the security, yes, that you might asking. So when we establish the connection, we create the service that broadcast themselves. So we expect to have only one peer. So after we found one peer, we close the connection itself, that discover the part. Also, I shared that we have a QR code. So inside the QR code, it's unique ID that we with what we provide this establish the service, and the validation step. It's not just the prompt. So there are some also parts. So we should be sure that our users are secure. So
Thank you for the presentation. I have a question. So you did everything manually, through
yes.
Wi-Fi Direct. Do you have any issues with it, with different devices, with different router types?
Yeah, of course. So just because we have variety of devices, it's not on the iOS part with only one. So each vendor can create or have the Wi-Fi on the different level. So it could be some issue that, for example, you start the connection, yes, but then you receive the call, or you are not just staying in the discovery mode, not discovery, broadcasting, and the system can kill your service. So in the it's better to not just for your service not to wait the connection, but from time to time send the discovery request. So you telling the system that I'm here, don't kill me. So it's a hack for that.
I have the same question, but I was wondering, could some vendors use different NDNS, little versus big Indian, and then you cannot even decode the bytes correctly, or it doesn't happen?
So we working with the Wi-Fi Direct that available on any Android device. So it's not from the code, it's not any different. But it could be that you test it on just, I don't know, between pixel and it works perfect. But then you took the Huawei and Samsung, and apparently there are some issues. So you it's better to investigate. And as I said, sometimes it system just killing the service, and it's better for you to send the packages out to tell the system that I'm here, not do not kill me.
No, I meant the sending, but I guess the Android takes care of it, right?
Yeah. So you just establish the connection and all the networking part, sending the IPs and so on and so forth. It's just handled by Android system. So you do
because then Android uses this, I think, this test suite to tell that this device is Android compatible. And I had issues in the past with some devices that were Android devices, but they were not fully compatible.
Mm-hmm.
So I guess in your case, that can be a lot of users not compatible.
Yep,
don't
yep,
know.
it could be.
Thank you for the presentation. I want to preface the question by saying that I've stopped using Viber like 8 years ago. Some of my family members still do use it though, those on the older spectrum, right? My question to you is basically a very nice feature, but Telegram did it a lot of time ago, like 10 years, and it was kind of like a killer feature for them. Could you please explain why did it take you so long to do it? What kind of difficulties you encountered? I believe it's because of the architecture or P2P, but if you could explain more, why?
Okay,
Why only now?
Yeah, thank you for the question. So I would say that way. Unfortunately, the market where you use your the Viber app, so you not see the whole super app ecosystem. And I would say that unfortunately some of the users lose other value of the app. So you don't see that actually behind the scene we working hard on other features like Lara said. So it's dating, it's fintech, it's e-commerce. So yeah, unfortunately, when you that huge, we actually have 4 apps inside. So it's hard to maintain some things. But if you will download the Viber after 8 years, I'm sure you will see that it's not the same as 8 years ago. So I encourage you to download and use end-to-end encryption.